Hi guys, this video today is going to cover how to factor when a is equal to 1. And when I say a is equal to 1, I'm talking about this term right here, like there's no number in front of the x, it's just 1. And so the way I do this is, some of you use the box method. You can use the box method. The box method, I think, takes a long time. So I have a little bit of a shortcut that I do. I'm not going to judge you for using the box method, but I do think you ought to think about other methods that might take less time. So what I do is I start setting up my parentheses. And I know it's going to be of two binomials, because all these problems are going to be two binomials basically. The x is all I have. Then I look at my 14, and I think in my head, what could I multiply to get 14? For instance, 1 times 14 or 2 times 7. There are no other options. It's just 1 and 14 or 2 and 7. Well, now I'm looking for which one of those factor pairs would add up to 9. And so 2 and 7 add up to 9. I'm going to put a plus 2 and a plus 7. And then I'm done. That's all I have to do. If you wanted to check it, you could go back and check it, and it should work. Let's look at number 12. Okay, once again, to start it, I'm going to start with two parentheses. And also, because they're all pluses, I know that my inside parentheses are pluses. We'll get to minuses in just a second. Then I look at my C term, my last term, and I basically think of what are the factors. I can multiply 1 times 20, I can multiply 2 times 10, I can multiply 4 times 5. Which one of those would add up to 9? Well, 4 and 5 add up to 9, so that's what we put in our parentheses. So that's how you factor a trinomial. Can you try number 13 and 14? I think that you'll find those pretty easy. So number 13, x plus 3, x plus 7. Number 14, it's a little bit tricky. It's x plus 2, x plus 3. And the reason I say it's tricky is that with 6, you could say 1 and 6, but 1 plus 6 is 7. If there was a minus sign in there, it might be that. And so let's talk about minuses now. Because I do want to talk about minuses, but I don't have a lot of minus examples, on number 16, let's change this to a minus 6x, and that way we can talk about the negatives there. Okay, but let's start with number 15. I would start, like I always do, with my two sets of parentheses. But now I have to take a second to think about my positives and negatives, because it's a negative 21. And so I have to think, well, one of them is going to be positive and one of them is going to be negative, because a negative times a positive is a negative. So I need one to be positive, one to be negative. Then, when I think about what multiplies to be 21, of course, 1 times 21 does. So does 3 times 7. And those are my only options. But the difference here is it wasn't 21, it was negative 21. So it could be negative 1 and positive 21, or it could be positive 1 and negative 20, positive 1 and negative 21. It could be negative 3 and positive 7, or it could be positive 3 and negative 7. So you have to consider all of those possibilities. And then what we're trying to do is see which ones would add up to be a negative 4. So of all these, which ones add up to a negative 4? It's going to be the positive 3 and the negative 7. And so in my parentheses, I'm going to put x plus 3, x minus 7. And once again, you could check it by multiplying it out and see if you get the right answer. Okay, number 16. Let's go ahead and, like I said, make this a minus in there. I started off my parentheses by putting an x here and an x here. I know I need to factor my 5 and say 1 times 5, and that's the only options because it's prime. But my middle term here is a minus. And so I need to think about that. 1 plus 5 doesn't equal negative 6, but a negative 1 and a negative 5 does equal negative 6. So that means in my parentheses, I need to have a negative 1 and a negative 5. They're both negative because a negative times a negative is a positive, but a negative plus a negative sometimes is a negative. In this case, it is a negative. Okay, we're going to continue on with that concept, but add in a little bit extra, which is a GCF. So in other words, I did the first one, already worked it out on your paper. We look for the GCF. The GCF here would be 2. So I factor out that 2, and that leaves me with this inside. And now I need to factor that, and the factors of 25 that add up to 10 are 5 and 5. Okay, let's look at number 18. What's the GCF? So it's 3. So we then divide out a 3. Okay, so now we've done that. Now we need to think about the factors of 20 that add up to 12. So now we're using this new trinomial, not the original one. We're using the new trinomial. So what multiplies to be 20? Well, 1 times 20, 2 times 10, 4 times 5. I'm looking for which ones add up to 12. 2 times 10. So my answer here is going to be 3 times x plus 2, x plus 10. So again, in this section, it's just the same thing. We're just adding in this extra component of the GCF. I think there's a lot of these, so let's skip number 20 for now. If you need to ask about number 20 in class, you can. Let's look at 21. I need to look for my GCF, which is 4. I'm going to factor out that GCF. Okay, I like this problem because it's continuing to talk about the negatives, which we haven't talked a lot about. So now we're going to factor out negative 20. It's not 20, it's negative 20. So that's where we come up with our negative 1 and positive 20, our negative 2 and positive 10, our negative 4 and positive 5, or the opposites, positives here and negatives here. Well, I can see that in this case it's going to be the 2 and the 10, right? I want to think about my sign. Do I have my signs right? They need to add up to positive 8. I do. I do have my signs correct. So I'm done with this problem. I need to write it out. So it's 4 on the outside, x minus 2, and x plus 10 on the inside. Take a second to do number 3. Factor out the GCF, and once you factor the GCF, go ahead and factor the trinomial. Okay, this one, the trinomial that was left, we factored out the GCF of 3, and then this looks a lot like that one above it, but it's a little bit different because the 8 is a negative instead of a positive. And so when I make my little list, I found out it was going to be 2 and 10, but I had to change the signs. It's a positive 2 and a negative 10 because it has to add up to a negative 8. And so that's going to be my solution, or excuse me, my final answer there for number 23. Okay, part C is those memorizing rules that we talked about on the page 1. So these are perfect square trinomials. Let me show you how I know they're perfect squares. X squared is a perfect square. 49 is a perfect square. That's a perfect square. So all of these, their A and their C, all are perfect squares. So A and C are the perfect squares. Now, we have to really look at the middle term and decide if that middle term is 2AB. Because remember, that was the rule, right? We always had an A squared, and then it was either plus or minus 2AB, and then plus B squared. So the 2AB is what we really need to look for. Okay, I've gotten ahead of myself, so let's just look at what we have. These are perfect squares. It's only a binomial. But that rule said if this is a perfect square and this is a perfect square and there's a minus in between them, then this is x minus 7, then this is x minus 7 and x plus 7. That is if it is a binomial to start. Then the reason is the plus 7x and the minus 7x will drop off. The only other one here that's a binomial is number, we've got 2 of them, 28 and 29. So 28, you have to basically take the square root of the terms. And so 28, the square root of 4x squared is 2x, and the square root of 81 is 9. And so it's 2x plus 9 and 2x minus 9. Now that square root, that's what we did with the 49, but it was just so easy we didn't think of it. When it has a leading coefficient like that, it makes it a little bit more difficult. But that is a perfect square, and that is a perfect square. Use that same logic and try number 29. Okay, so square root of 121x squared is 11x. Square root of 25 is 5. So it's 11x plus 5 and 11x minus 5. That's if it's a perfect square binomial. Difference of squares is what it's called. That is, you have a subtraction and you've got a perfect square minus a perfect square. Now the other ones are trinomials. And so interestingly, they get shorter. Like this one was short and it got longer. This one's longer, it's going to get shorter. In other words, both of these are pluses and the square root of 36 is 6. And so this is x plus 6 quantity squared. And again, you can multiply that out and double check it, but that is right. And the reason I know it's right is that the middle term is 2ab. Okay, a was 1, b is 6. The middle term is 2 times 1 times 6. Let's look at number 27. Okay, a similar deal. It was a trinomial. It's going to get shorter. It's going to be 1 binomial squared. We're looking at the 16, but notice there's a minus there. So it's going to be x minus 4 quantity squared. And again, you could check it by multiplying it out. Once again, the middle term is 2ab. 2 times x times 4 times negative 4 is negative 8x. Okay, similar thing on number 30. It's a little bit more complex because we need to square root all of that. So it's a trinomial. It's perfect squares. Let's talk about the 2ab at the end. So I'm going to guess that this is a 3x. They're all pluses, so this is a plus, and that's an 8. So I'm going to square that. I need to check my 2ab. 2 times a times b would be 2 times 3x times 8. And 2 times 3x times 8 is 48x. And so my 2ab does come out to be 48x, and so I know this is the right answer. Okay, as far as summary goes, there's a couple things that you could concentrate on in your summary. One might be from the first set to factor a trinomial where a equals 1, you just look for the factors of c that add up to b. Look for the factors of c that add up to b. That might be one thing you write in your summary. Another thing is you might write in if there's a leading coefficient, look into factoring GCF first. So factor out the GCF before you factor the trinomial. That might be another thing you would write in your summary. Finally, you might say something about the rules, that it's helpful to memorize the rules, but you don't have to. One thing I didn't mention is that you can do these with the box method. So for instance, if I look at number 27, I can set up number 27 as a box method problem. I don't remember the box method very well, but I think it's something like this. Then you have to figure out what goes in here. But anyway, you can do them by the box method. Even number 5 or 25, you could do that. It's just that you don't have any x's, but that means that they add up together. So now I'm remembering the box method, so this will be a minus 7x and a plus 7x here, and those cancel out. But anyway, you can do the box method on these if you are a big fan of that. Okay, so hopefully you've got a summary. We will work on factoring a lot in the next couple of days, in the next couple of weeks.